Hello everyone and welcome to this next session of the CCNA online training program. Now in the previous session or before the weekend I should say that we had completed with the first module, that is building a simple network. Okay. Today what we are going to start off with is the next module, that is the next step towards setting up a network, that is establishing internet connectivity. Okay. Now when I say internet, we are not really going to talk about the various internet connectivity options and all that, but in this particular module we are going to more focus upon the TCP/IP network layer. Okay, that is with regards to the OSI model, we are going to focus on layer 3, that is the network layer. Okay, so out here we are going to talk about IP addressing, the basics of IP addressing. Then we are going to talk about binary to decimal, decimal to binary conversion. We are also going to discuss about things like how to determine or what is the concept of a subnet mask, how to determine a network ID from a given IP address and a subnet mask. Okay, so many different concepts is what we're going to talk about, but all of them would be related to the network layer or IP addressing in general. Okay, so that's what we're going to talk about in this section here. So to start off with this particular topic, we'll first try to understand the TCP/IP internet layer. Okay, now if you compare the OSI model and the TCP/IP model, so the TCP/IP internet layer relates itself to the OSI model network layer. Okay, so that is what it does, and that's what we are going to discuss about today. Okay. So saying that, when I talk about the internet protocol or IP in general, okay, it operates at the network layer of the OSI model, as I mentioned before. It is a connectionless protocol. Okay, now I cannot mention about IP as connection oriented at all. Why? Because whenever I talk about an IP, okay, or internet protocol, it is just used as an identifier for devices to communicate with each other, or to determine a particular destination where I want to send packets or traffic. That's where I would make use of the IP. Okay, so that's why I would call IP or internet protocol as a connectionless protocol. Okay, so whenever I talk about layer 3 or internet layer, okay, with regards to the TCP/IP model, the data that is transmitted at this particular layer is called as packet. Now in the previous session, if you remember, we were talking more about layer 2. So talking about layer 2, the information that is passed is called as a frame. But here, whenever we talk about the internet protocol, the information that is passed is called as a packet. Okay, so whenever we talk about a packet, each and every packet is treated independently. Okay, now what is the format and the structure of a packet? We'll definitely have a look at it. But then remember this, when it comes to the internet protocol or this particular layer here, it is more about packets that we are going to discuss about. Okay, so in that case, we also need to understand about hierarchical addressing. Okay, now whenever we talk about transmission of these packets, okay, they are based upon the best effort delivery. Okay, and there are no data recovery features. Now what I mean by data recovery feature is, whenever I transmit a packet, okay, if the information in that packet is lost, then there is no way of recovering that information which is lost. Okay, because internet protocol as a protocol doesn't have the characteristic or doesn't have the feature to recover data. The only thing that it can do is it can find out the destination or search for the destination and take the information to the destination. That's it. Okay, it is not involved in data delivery, or it's not involved in error correction or error recovery or data recovery in general. Okay. Another important thing is internet protocol is media independent. Now what I mean by that is, any sort of media you make use of. Now whenever we talk about that, it can be Ethernet, that is wired network or wireless network. Okay, it can be fiber optic connection, or it can be a copper cable connection, or it can be a wireless radio wave. Any form of communication you talk about, okay, IP is not at all related to that, or internet protocol does not depend on the media that you make use of. Okay. Now there are two versions or variations to the IP or Internet Protocol. We have Internet Protocol version 4 and Internet Protocol version 6. Okay. Now before we move on into further details about this topic, let's first quickly discuss about these two variations that are available with regards to Internet Protocol. Okay. Internet Protocol or IP version 4, okay, is a 32-bit address. Okay, whenever we talk about Internet Protocol version 4 or IP version 4, it is a 32-bit address. Okay, now why do I call it as a 32-bit address? Okay, that's because it is an identifier value, okay, which is of 32-bit, and it is assigned to individual devices. Now those devices can be a switch, it can be a router, or it can be a PC like a laptop or a desktop. In either of the cases, all these devices need to have an IP address. Okay, like if you remember from the previous session, we talked about assigning an IP address to a switch. What is the purpose of that? So that we could connect to that switch remotely. Or if you remember the lab exercise that we were working upon, okay, the lab exercise was about the PC communicating with the switch. Okay, now how was that possible? Because both the PC as well as the switch had an IP address. Okay, and they were communicating with each other based on the IP address. So bottom line is, whenever we talk about IP version 4, it is a 32-bit address. Okay, so we'll understand it more as we go along in this particular course. But remember this, IP version 4 or Internet Protocol version 4 is of 32-bit. Whereas Internet Protocol version 6 or IP version 6, when I talk about it, that's the new version of Internet Protocol available, and it is of 128-bit. Okay, so whenever we talk about IP version 6, it is 4 times larger as compared to IP version 4. Okay, now why was IP version 6 introduced? Well, one of the major reasons behind it was IP version 4 is slowly getting exhausted. Okay, in fact, as we speak, I should state that there are very less IP addresses available when it comes to IP version 4. Okay, and another important aspect is IP version 4 does not have much of security. Okay, so considering that IP version 6 was launched, now one thing is, since it is 128-bit, which means it is larger, it can accommodate or it can provide you with a lot of IP addresses. Plus, secondly, it offers you inbuilt security. Okay, it has a built-in security feature of encryption and so on. Okay, so that means both the drawbacks of IP version 4 are taken care of. You understand? Okay, so that's the main thing. IP version 4, okay, has no security in it and it's slowly getting exhausted. But whenever I talk about IP version 6, okay, it is secure, and at the same point of time, it gives you a lot of options with regards to the number of IP addresses. Okay. Now, going along, let's talk about why do we need an IP address. Okay, like I told you before, an IP address is like an identifier that I give to individual devices so that they can communicate with each other. Okay, so bottom line is, whenever we talk about communication, okay, minimum 2 devices need to be involved for communication, right? But then unless and until those 2 devices do not identify each other, they cannot communicate. I mean, think about it in terms of humans. Like, if 2 human beings need to communicate with each other, they need to know something about each other. They need to identify each other. That's when they can communicate. Same thing applies here. Okay. So IP addresses uniquely identify each device on an IP network. Okay. So whenever we talk about every device, okay, the device is commonly referred to as a host. Okay, so that host can be a computer, or it can be a switch, or any other networking device like a router, or it can be a wireless access point. Okay, so any networking device you think about, they need to have an IP address. Okay, but then every device needs to have a unique IP address. Okay, now what I mean by that is, if at all I talk about a single network, okay, or in general at this particular level, let me put it up in the form of a single LAN. Okay, so if I talk about a single LAN, okay, every device within that LAN needs to have a unique IP address. Okay, it is like every person needs to have a different name. Otherwise there would be confusion, right? Same way here, every device needs to have a unique address. Okay, so a unique address means a unique IP address. That's what we're talking about here. Okay, now with regards to an IP address, okay, we need to understand a formula here. Let me just quickly type it down for you. Okay, there is a very simple formula that you need to understand with regards to an IP address. That is, let me just also change the color, otherwise you won't be able to see it. Okay, so that is IP address is equal to network address plus host address. Okay, so that's one simple formula that you need to understand. IP address is equal to network address plus the host address. Okay, now let's talk about what is this network address and what is this host address. Okay, let's first discuss about network address. Network address, also referred to as network ID, is nothing but an identifier that is used to define a network, an IP network. Okay, so whenever we talk about an IP network is identified using a network address. You understand? Okay, so all the nodes or all the hosts within a single IP network can communicate with each other. Remember this. All the hosts within a single network address can communicate with each other. Okay, so what I mean by that is, if two computers or two devices belong to the same IP network, they can communicate with each other. Okay, so when I say that two devices belong to the same IP network, what I mean by that is, both of those devices or both of those computers will have the same network address. So if they have the same network address, they would talk to each other or they would communicate with each other. You understand? Okay, but if two devices belong to two different network addresses, okay, they cannot communicate with each other unless and until we have a router between them. Okay, like earlier in my previous sessions, if you remember the definition of a router that I gave you, I told you that a router is a device used to communicate between two different IP networks, right? Okay, so if at all two devices belong to two different network addresses, and if they need to communicate with each other, the only way they can do that is by using a router. Okay, but if two devices are talking to each other, which means, okay, like there is no router, and if two devices are talking to each other, which means they belong to the same IP network. Okay, so two devices belonging to the same IP network communicate with each other. Do you get that now? Understood network address at this point? Okay, I'll elaborate more on this, but I hope at this point you're clear with the term network address. Okay, let's now get on into the second part, that is the host address. The host address is also referred to as host ID. Okay, host address is also called as host ID. Okay, now to understand this better, okay, let me just compare it with a school. Okay, whenever we talk about a school, like schools in India, mostly if you refer to it to them, how do they work? Well, every school, when I talk about it, they have various classrooms, right? Okay, but even before we jump to the classrooms, okay, whenever we talk about a school has various standards. Standard means standard 1, standard 2, or level 1, level 2. You know, different locations have different names that they give to different like these sections. Okay, so some people call it +1, +2, and some people call it standard 1, first standard, second standard, third standard. So a particular standard, when I talk about it, contain children of a particular age group, right? They are working on a particular academic level. That is what it means, right? But within a standard also, okay, like when I talk about a particular school, within a standard also, there are various divisions. What I mean by that is, you may have division A, division B, division C, and so on. Okay, because the classrooms may have a capacity of 60 people, let's say, or 60 children. So in that case, just to divide them or just to accommodate all of these children together into a single school, okay. So what they do is they divide this entire standard into different divisions. Okay, so then you would have standard 1A, 1B, 1C, 1D, 1E, and so on. Okay, so these divisions, when I talk about it, it refers to a classroom. Do you understand? Okay, so each division is like a classroom. So what I do is, for explanation sake, a network address can be called as or can be referred to as a classroom. Okay, so if you notice, while the school is on, okay, a child from one classroom cannot communicate or cannot talk directly with a child in another classroom. Do you agree? A child in one classroom cannot talk to another child in another classroom. Okay, so two different classrooms cannot talk to each other. Same thing applies here. Two different network addresses cannot communicate with each other directly. Do you understand that? Okay, but within a classroom, all the children can talk to each other. So each child can be compared with a device or a host. Do you understand that? Okay, so a classroom can be compared with a network address, and a child within a classroom can be compared with a host like a networking device. Okay, so within a classroom or within a network address, all hosts can communicate with each other. Okay, but then now let's dig deeper into a classroom. So whenever we talk about a classroom now, within a classroom, okay, each child may have its own roll number. Okay, now what is this roll number used for? Roll number is like an identifier for each and every child, right? Okay, so like we have roll number 1, roll number 2, and if a classroom has 60 children, then in that case we'll have up to roll number 60. Okay, but all these 60 children can talk to each other, right? Okay, so that roll number can be compared with a host ID. Do you understand? Okay, so whenever we ask a child like which class do you study in, okay, what does the child respond back in? I study in standard 1A, for example, and my roll number is 25. You know, so that's what they say. I mean, they talk about both of them. Okay, so both of them form the identifier for the child, or both of them together, like that is the classroom number plus the roll number become the identifier for the child. Same way, whenever we talk about a network, okay, whenever we talk about a node, an individual node, it will have two components to it: the network address and the host address. So if I combine the network address and the host address together, that's when I get the IP address. Okay, so whenever I assign an IP address to a particular node, it is actually a combination of a network address and a host address. Are you clear about that now? Understood the terms network address and the host address? Okay, great. Okay, so let's now elaborate further on it. As I told you before, an IP address together is of 32-bit. Okay, IP address is of 32-bit. Now these 32 bits are divided into 4 different sections. Okay, these 32 bits are divided into 4 different sections, each section of 8-bit each. Okay, so you have 8-bit. Okay, then you have a dot, then you again have 8-bit, a dot, 8-bit again, a dot, and then 8-bit. Okay, so that is how an IP address is represented. Okay, so you have 8 bits, dot 8-bit again dot 8-bit, and then again a dot and then 8-bit. Okay, so each of these 8 bits are called as an octet. Okay, so 8-bit, okay, is called as octet. Okay, so an IP address, whenever we talk about it, okay, is divided into 4 different octets. Okay, now how is that possible? Because the IP address is of 32-bit, and if I divide it into 4 sections, each of the sections are called as an octet, which is of 8 bits each. So there are 4 different octets, and ultimately whenever we talk about an IP address, each of these octets, whenever I talk about it, they are represented in decimal numbers. Okay, so whenever we talk about an IP address, each of these octets are represented in decimal format. You understand? Okay, so you would have each of these octets, rather than defined in bits, they are defined in the form of an octet. Okay, so let me give an example of an IP address. Okay, so let's say the example would be 192.168.10.100. Okay, so if I talk about that, do you see those dots between each of those numbers? So each number is a decimal representation. Okay, like 192 is a decimal number, 168 is a decimal number, then you have 10, another decimal number, and the fourth decimal number is 100. Okay, but whenever we talk about this IP address of 192.168.10.100, it is actually a combination of network address and host address. Do you understand that? So whenever we talk about an IP address, it is a combination of network address and the host address. Do you get that now? Okay, but one of the main thing that you need to understand is, okay, this IP address which you look at it here, the left portion is the network address and the right portion is the host address. Again, let me repeat it. Whenever we talk about network address, the left portion is called as the network address and the right portion is called as the host address. Okay, so be very clear on this, do not forget it, because it is based on this concept that we are going to understand IP address better. Okay, so the left portion of an IP address is called as network address and the right portion of the IP address is called as host address. Okay, but how do we understand what is the network address and what is the host address? Okay, so to understand or to differentiate between the network address and the host address, we have a subnet mask. Okay, so now we come back to the next statement or the next concept of a subnet mask. Okay, so what is a subnet mask? A subnet mask is a value that is used to define a network address and a host address. Okay, so what is a subnet mask? A subnet mask is a value that is used to define a network address and a host address. Okay, so just by looking at an IP address, you cannot make out whether what is the value of a network address and what is the value of host address. To know the value or to derive the network address and the host address out of an IP address, you would need to have a subnet mask. You understand? So you need to have an IP address and a subnet mask, and based on that, you would get to know the network address and the host address. Do you understand that now? Clear about this? Okay. Okay. Now, before we get on into further details about subnet mask and so on, let's now try to understand this concept of the binary to decimal conversion and decimal to binary. Okay. Now, why is that important here? Because from the representation on the screen itself, if you see, okay, an IP address is represented in decimal numbers, right? But an IP address is actually calculated in the terms of bits. So it's very important for us, okay, to understand this bit or binary to decimal calculation, okay, or decimal to binary calculation. Okay. Another important aspect is, even though we as an end user would make use of this as an IP address, the computer does not understand this value. The computer has to convert this into binary. That's why we need to also understand the conversion from decimal to binary and binary to decimal. Do you understand that? Okay. So let's get along. Okay. Now, whenever we talk about the IP header, okay, the IP header which is added at layer 3, typically the IP header has all of these fields inside it. Okay. Now, whenever I talk about all of these fields, okay, as you see here, 10 bytes is what they are using out here. Like, you know, the version and the IHL together form 1 byte. Then the service type is another 2 bytes. The packet length is of 7 bytes. Okay, so each field has its own size. Okay, but then along with that, the most important part that this IP header carries is the source address and the destination address. Now, when we talked about the layer 2 or the Ethernet frame, there also we had the source address and the destination address. But that source address and destination address was the layer 2 source address and the layer 2 destination address. But when we talk about the IP header, in the case of an IP header, we have the source address and the destination address as layer 3. Now, what is this layer 3 source address and destination address? That is nothing but the IP address. Okay, so whenever we talk about the IP header, it will have the source IP address and the destination IP address. That is what it holds in an IP header. Do you understand? Apart from that, it has an options field and a padding field. These are the various fields that make up the IP header. Do you understand that? Okay, so an IP header most importantly has these two fields inside it, the source address or the source IP address and the destination IP address. That is what it has inside the IP header. Okay, now let's talk about binary, and ultimately we'll talk about the decimal to binary conversion. Okay, now to do that, what I'm going to do is I'll just stop the sharing for the while. Okay, I'll just pause the recording for a moment. Okay, so for explaining this concept of the binary to decimal and decimal to binary conversion, I'm going to make use of the whiteboard. So, okay, can you see the whiteboard right now?
No, sir. Yes.
Okay, so in this particular section, okay, so let me just take an example and then accordingly we'll talk about it. Okay, so let's first talk about this concept of binary. Okay, now as you can see here, the text is in yellow, so let me just change the color. Okay, so why is it called binary? Let's talk about that. Whenever we talk about binary, okay, binary means two. Okay, binary means two numbers, okay, or two separate digits. Okay, so that is what it means. So whenever we talk about that, whenever we talk about binary digits, okay, it can be a 0 or a 1. Okay, these are the two values that you can have in the case of binary. It can be 0 or it can be 1. Clear about that? Okay. Now saying that, okay, whenever we talk about binary to decimal conversion, okay, since we are talking about an IP address in the form of 32 bits, okay, I think the microphone is causing some sort of an echo because I can hear my own echo. Okay, yeah. So whenever we talk about binary conversion here, okay, since we are talking about conversion from decimal to binary and binary to decimal, okay, we are talking about this conversion with regards to an IP address, and the maximum we go up to in the case of an IP address is 8 bits. Okay, so that's why for this understanding of binary to decimal conversion, we are only going to consider 8-bit binary numbers. Okay, so remember that in our particular course, and when we learn about this binary to decimal conversion or decimal to binary conversion, we are going to limit ourselves to 8 bits only. Why? Because whenever we talk about an IP address, each octet is of 8 bits. We are not going to go beyond that. That's the reason we are going to limit ourselves to 8 bits only. Do you get that? So talking about that, okay, whenever we talk about these 8 bits, okay, these 8 bits are typically represented in this fashion. Okay, you have a table which you need to remember. Okay, so let's talk about the table here. Okay, so the table goes something like this: 2 raised to 8. Okay, now I hope you understand what I mean by 2 raised to 8. Okay, that is 2 you multiplied by 2 2 by 2 by 2 and so on up to 8 times. Okay, that's what you do. 2 raised to 8 is the first value. 2 raised to 7 is the second. 2 raised to 6, sorry about that. Then you have 2 raised to 5. 2 raised to 4. 2 raised to 3. 2 raised to 2. 2 raised to 1. Okay, now I think I made a mistake here. Actually, it's supposed to start with not 2 raised to 8, but instead 2 raised to 7. That's where it's supposed to start. Okay, I'll explain this to you, but let me just put down the table and then we can talk about it. Okay, now, oh, you can't see the screen. Okay, just a minute. Can you see it now? Okay, great. Okay, can you see what I'm doing right now? Oh, okay. Okay, now can you see it? Okay, just a minute. Okay, so as I was talking about it earlier, whenever I talk about binary numbers, okay, binary numbers can be either 0 or 1. Okay, that is what you can have. So to understand this conversion from binary to decimal or decimal to binary, we are going to consider a maximum of 8 bits. Okay, just because each and every octet within an IP address is of 8 bits. Okay, so let's talk about it more. So saying that whenever we talk about this conversion, we need to understand a table for that. So that table would be 2 raised to 7. That's where it starts off with. Then you have 2 raised to 6. Okay, I'll explain it to you, but just let me make a note of it. 2 raised to 5. 2 raised to 4. 2 raised to 3. 2 raised to 2. 2 raised to 1. And then 2 raised to 0. Okay, now what is this about? Whenever we talk about 8 bits, okay, typically those 8 bits starts off with 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so 0 through 7, that's what makes it 8. Okay, another important thing about binary numbers is, okay, given a binary number, like let's say I give you a simple example of a binary number. Okay, now that's an 8-bit binary number. Okay, now if you look at these 8-bit binary numbers, this 0 that you see on the rightmost portion is called as the least significant bit. Okay, so this 0 that you see here is called as Okay, LSB, that is least significant bit. Okay, and this rightmost one that you see, sorry, leftmost one that you see here, okay, is called as MSB, that is most significant bit. Okay, so whenever we talk about a binary number has two portions to it. We have the leftmost bit and the rightmost bit. The leftmost bit is called as most significant bit, and the rightmost bit, that is 0 in this example, is called as the least significant bit. And whenever we talk about starting counting of bits, okay, it starts off from the right to the left. Okay, that is how it goes. Okay, it is not left to right, but it is right to left. Okay, so that's the reason you find 0 on the right and then 7 on the left. So 0 through 7 becomes 8 bits. Okay, now for conversion from binary to decimal, you have to convert or multiply it by 2, because like I told you before, binary number is made up of two separate numbers, 0 or 1. Okay, so that's why we have 2 raised to the appropriate value. Okay, so that is 2 raised to 0. That is the least significant bit. That is how it would be represented. Okay, so in terms of values now, if I convert this accordingly, okay, so 2 raised to 7. Do you know what is the value of 2 raised to 7? Do you know that? Okay, it is ultimately 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, 2 and 2. Okay, so that is what you need to do. 2 raised to 7. Okay, well, 256, the answer that I've got here is with regards to 2 raised to 8. Okay, because 2 raised to 7, if you look at it, it is 128. See, 2 multiplied by 2 is 4, 4 multiplied by 2 is 8, 8 by 2 is 16, 16 by 2 is 32, 32 by 2 is 64, 64 by 2 is 128. Okay, so 2 raised to 7 will be 128. Okay, do you get that? Then let's talk about 2 raised to 6. 2 raised to 6 is nothing but 64. Okay, 2 raised to 5, if you look at it, it would be 32. 2 raised to 4 would be 16. 2 raised to 3 would be 8. 2 raised to 2 would be 4. 2 raised to 1 would be 2, and 2 raised to 0 would be 1. Okay, so remember this in mathematics when we talk about it, 2 raised to 1 is 2 raised to 0 is always 1. Anything raised to 0 is always 1. Okay, so that's the kind of a table that you need to remember for converting from binary to decimal. Okay, that's the table that you need to remember. Okay, so now let's take a look at some examples to understand this better. Okay, now what I'll do is, just to understand it further, I'm just going to cut it, open up WordPad. Okay, because WordPad will give you a much better view and make you understand better. Okay, so okay. I'm just spacing them so that they appear differently or distinctly. Okay, so that is how the table was, okay, which I had represented before. And I'll just mark them in a different color so that it's visible. Okay, so that's how I'll leave them. So this is the table that we have. Okay, now whenever we talk about the table, okay, you have to first take in the binary number, whatever is given to you, and you have to put it into this table. Okay, that is how you're supposed to do it. Okay, so let's say we'll take our first example to understand this. Okay, so to understand the first example, okay, the binary number that I'll give you, let me just take it up. Okay, so binary number that we are going to consider here would be 1, just 1. Okay, let's take the binary number of 1. Okay, now if I talk about the binary number of 1, okay, here you find that it is just of one single number, right? Just one single binary number, and as I told you, the numbering starts off from left to right to left. Okay, so if I want to put it into this table, it's going to be in this fashion. Okay, it would be typically you have to first convert this number into 8 bits. How would you do that? To convert it into 8 bits, you would have to typically add some zeros in front of it. In the sense, you have to put it in this fashion: 0 0 0 0 0 0 0 and then 1. Okay, so I'm adding 7 zeros in front of it, and then I'm putting up this 1 here. Okay, so that is what this binary number would be. Are you clear about this? What I'm only doing is this single bit, I'm converting it into the format of 8 bits. That's what I'm doing out here. Did you understand what I did out here in this section? Okay, so accordingly now, if I put it into this table, the first value is going to be 0. Second value, okay, now let me just change the color here. Okay, the second value is again going to be 0. Third value is again going to be 0. Fourth value is also 0. Fifth value is also 0. Sixth is also 0. Seventh is also 0, and the last bit is going to be 1. Okay, so the blue number that you see here is going to be the binary number. Okay, now let's calculate the appropriate decimal value. Okay, now to understand or to calculate the appropriate decimal value, okay, just understand the simple logic. Okay, well, in fact, this is something that you learn even in schools and when you do your academics. Okay, that's how you people are taught about binary and decimal values. Well, the logic is quite simple. 0 is off, 1 means on. Okay, like you have an on-off switch, right? Okay, so remember this: 0 means off, okay, and 1 means on. That is what you need to remember. So 0 means off and 1 means on. Okay, now with regards to this table, 0 means do not consider, ignore, and 1 means consider. Okay, again let me repeat: 0 means do not consider and 1 means consider. Okay, so that is what you need to consider. So 0 means off, means do not consider, and 1 means on, means consider. Clear about that? Okay, so 0 means off or consider. Let me just write it down for you. 0 is off or consider. Okay, and 1, if I talk about it, 1 means on. Sorry. Okay, not consider, and 1 means on, that is consider. You understand that? Okay, so that's the logic that you need to make use of. Okay, so accordingly, now according to this particular value that you see here, okay, what you have to do is you have to ignore all the zeros. So what you effectively see is you would not consider these values at all. Okay, you would have to just look at the value that is 1. Okay, so where is this 1 located? 1 is directly located on this particular value, that is 1. So effectively this binary value represents a decimal value of 1. Okay, so this binary value of 1 represents a decimal value of 1. Do you understand that? Okay, so always remember this. Whenever you're given a binary number, okay, you have to first convert it into 8 bits. Okay, and now how would you convert it into 8 bits? Okay, if it is less than 8 bits, just add zeros in front of that particular number. Okay, and that's what I did out here. I added 7 zeros out here, and that's how I got this particular value. Okay, let's take another example so that we understand it much better. The next example that I'm going to take is, okay, before I continue to the next example, do you have any questions with regards to this, or are you guys absolutely clear with this particular binary to decimal? Okay, it seems everyone is fine. Okay, so let's continue. The next example that I'm giving you is 1 0 1 0 1 0 1 and 0. Okay, that's the binary number that we are going to look at. Okay, again, if you notice, this binary number that you see here is all 8 bits. So since it is already 8 bits, we are not going to convert it to anything else. Do you understand? We are going to leave it as it is. So accordingly now, if I try to convert it into decimal, how will that be? Okay, so let me just put it down here. Okay, so the decimal value, if I want to calculate it, again the logic is going to be the same. 1 means consider, 0 means do not consider. Okay, so accordingly it is going to be 1 means consider, right? So all the ones I'm going to add them up. So 128, that is the first one. Second one corresponds to 32, so plus 32. Okay, third one corresponds to 8, so plus 8. Okay, fourth one corresponds to 2. Okay, so plus 2. Okay, so that is what you're supposed to do. Clear? You're supposed to add all the numbers corresponding to the ones. Okay, so it is going to be 128 plus 32 plus 8 plus 2. Okay, now how much does that come out to? The total value it comes out to is 170. 170. Okay, so this binary value that you see here corresponds to 170. Do you understand that? Any questions on this particular part? Okay, in fact, a lot of people find this confusing, but I hope you are very clear with regards to these things that I've just covered. Let's take one final example before we proceed on to the next part. Okay. So the next value that I'm going to take is 1 1. Sorry, 1 1. Okay, 0 0 0 0 0 and 0. Okay, let's take this example. So according to this example now, if I want to convert it into decimal, can you tell me what that value it would be? What is the decimal corresponding decimal value which this binary number represents? Yes, absolutely right. It's 192. Okay. Now since you were so quick with regards to this particular question, let me give you another. Okay. Okay. Tell me the value for this binary. Yeah, absolutely right. It's going to be 255. Okay. In fact, it's one of a good ways, in which you can sharpen your mathematics skills of addition and such kind of a thing. But yeah, remember this: all the 8 bits if they are ones, which means it is going to be the corresponding value of 255. Okay, I'll come back to this particular concept of all ones a bit later, but yeah, that's one of the things that you need to know. Okay, similarly, if I have all these bits as zeros, okay, the corresponding decimal value is also going to be 0. Do you understand? Okay, so if all the bits are zeros out here, the corresponding decimal value is also going to be 0. Okay, so do you have any questions with regards to conversion from binary to decimal? Okay, great. Now let's get on to the next part. Okay, the next head that we are going to talk about is decimal to binary. Let's talk about that conversion. Okay, so decimal to binary, that's what we are going to talk about next. Okay, so talking about that. Okay, well, let me give you an example of a decimal value first, and then we'll try to convert it into binary. Okay, so the decimal value that I'm giving you, let's say it is 200. Okay, that's the value that we are going to talk about. Okay, now how do we derive the binary value for this value or decimal value of 200? Okay, let's talk about that. Well, again for that we have to refer to the same table that we talked about before. Okay, these two values, that is what we're going to talk about. Okay, now to calculate this value of 200, what you're supposed to do is you have to start right from the left hand side, the highest value. Okay, the highest value is on the left hand side, right? So you have to start off right from 128. Okay, now 128 is less than 200. Do you agree? Okay, so accordingly now, okay, you have to put a 1 below 128. Do you understand? Okay, 128 is still less than 200, so you put up a 1 below 128. Then the next value that we have is 64. Okay, now this next value that we have is 64. Now if I add 128 plus 64, okay, that becomes 192. Okay, 128 plus 64 becomes 192, and 192 is still less than 200, right? So in that case I have to put a 1 below 64 as well. Okay, again let me repeat, 128, that is the previous one, plus 64, okay, that becomes 192, and 192 is still less than 200, so that's why I need to put a 1 below that. Do you understand? Okay, next 32. Now 192 plus 32, if I put, that becomes 224, but 224 is greater than 200. Do you understand? Okay, so 192 from the previous calculation plus 32 becomes 224, but 224 is greater than 200. So that's why I'm going to put up a 0 out here. So remember this, you have to put up a value of 1 below all the sections where it is below a value of 200. Okay, so out here if I add 32, it is going to be 224, which is greater than 200. That's why I put up a 0 in the third column. Okay, the fourth column is 16, so 192 plus 16. Okay, if I add that, it's going to be 208. 192 plus 16 is 208 or 208. 208 is more than 200, so that's why I'm going to put up a 0 out here. Do you get that? Okay, the next column is 8, that is 192 plus 8. 192 plus 8 is going to be 200, exactly 200, right? So that's why I have to put up a 0, and everywhere else it's going to be a 0. Sorry, under 8 I'm going to put up a 1, and everywhere else it's going to be a 0, because I have achieved this value of 200. Okay, so effectively this is the binary value for 200. Did you get the concept here? Okay, great. Let's take another example to understand this further. Okay, the next example that we are going to take is going to be 224. Okay, so let's take an example of 224. Okay, so accordingly now let's start off again with the same logic. Okay, so the first section is 128. 128 is less than 224, so I have to put up a 1 here. Okay, the second section is 64, so 128 plus 64 is 192, and 192 is less than 224, so I need to put up a 1 here. The next section is 32, so 192 plus 32 becomes 224, and 224 is equal to this 224 value that we need to achieve, so I need to put up a 1, and everywhere else it's going to be a 0. You understand? So this is going to be a binary value or binary equivalent for 224. Do you understand this particular example? Okay, let's take another example and then we'll proceed. Okay, so the next example that I'm going to give you is, let's say, 196. Okay, so let's take an example of 196. Now, can you calculate the value and give it to me for 196? Follow the same methodology. It would be absolutely easy for you to work upon. Okay, so according to you, okay, the answer is 1 1 0 0 0 0 and then 1 and then 0. Okay, now let's try to check that. Okay, well, according to that, 128, that is this first one, 128 plus 64 becomes 192. Okay, and then 0 0 0, and then this is 2. So this is supposed to be 194. This is not 196, which means it is incorrect. Okay, so I think do you have a wrong table? Please check it up. Okay, but this is the table that you need to follow. So effectively, the value is going to be 1 0 0. Okay, this should be the actual value, 1 1 0 0 0 1 0 0. This is what is 196. Can you check that up again? Yeah, but can you check this solution of yours before we continue? Okay, okay, great. So let's go in for another example. Okay, so the next example that we are going to talk about is 172. Okay, so that is what I want. So 172. Get the value for 172. Okay, so what you have got is, let me put it down, 1 0 1 0 1 1 0 0. Okay, so let's check it up. Okay, so accordingly now it is 128 plus 32, that becomes 160, 168 and 4 172. That's absolutely right. Okay, so this is the value, or this is the binary value for 172. Okay, let me give you one more question. Okay. Okay, so okay, the value that we're looking at is 96. And I'll give you one more question so that you complete both of them. $155. Okay, so look out for or search for the values of both of them, 96 as well as 155. Okay, so one of the responses that I've got from you is, okay, yeah, for 96 it's perfectly all right. Okay, so the value for that is typically 0 1 1 and then rest all zeros. That's perfectly right. Okay, so that's for 96. Now search for 155. Okay, so let me just put down the solution that you've given. So 1 0 0 1 1, then 0 1 and 1. Okay, so that's the solution that you've given. So let's check whether it's right. So 128 plus 16, that becomes 144. 144 plus 8 becomes 152. Okay, and then 154 and 155. That's absolutely right. Okay, so I hope now you're absolutely clear with how to convert from decimal to binary. Do you have any questions with regards to how to do this? Any doubts? Okay, great. Okay, so this was one of the things that you need to know. Okay, now let's talk about the next section. The next section that we are going to deal with. Okay, the next section that we are going to deal with is about the and OR logic. Okay, so it's called logical and logical OR. Okay, so these are the two things that we need to talk about next. Okay, so logical and logical OR. These are the two things that we need to talk about. So when we talk about logical and logical OR, okay, well, let's understand this. A logical AND means, okay, if there are two binary values, 1 and 1. Let's say if you AND both of these numbers, okay, if you put up a logical AND between 1 and 1, that is you try to AND 1 and 1, another binary number of 1, the resultant value that you get is going to be 1. Okay, that's the logic here. Whereas if I talk about logical OR, okay, so if you put 1 or 1, okay, the resultant value that you get is 1. Okay, do you get that? Okay, that's the OR logic and the AND logic. Now let me give you another example. 1 and 0 is going to be 0. Okay, whereas when I talk about 1 or 0, it's going to be 1. Okay, then 0 and 1 is going to be 0, whereas 0 or 1 is going to be 1. Okay, and then when I talk about 0 and 0, it's going to be 0, and 0 or 0 is going to be 0. Okay, so these two things is what you need to understand next: the logical and the logical OR. Okay, in fact, I remember it in a simpler way, a different way. In fact, I mean, I'm not sure whether it would be simpler for you guys, but then for me, I simplify it by understanding it in this manner. And logic, I use the multiplication. You know, when we multiply some values, so 1 multiplied by 1 is always 1. 1 multiplied by 0 is always 0. 0 multiplied by 1 is always 0, and then 0 multiplied by 0 is 0. Okay, so that's the logic I follow for logical AND. That's how I remember it. But for logical OR, I make use of addition. Okay, but the only difference is when I add 1 and 1, okay, in terms of binary, the resultant value would be 1. Okay, so that's how I treat it. So for logical AND, I use multiply, and for logical OR, I make use of addition. Okay, so 1 or 1 is 1, but 1 or 0, that is 1 plus 0 would be 1. 0 plus 1 is also 1, or 0 plus 0 is 0. Do you get that now? Understood these two tables, logical AND and logical OR? Okay, great. Okay, now the next concept. Okay, so here I'm just trying to clear out some basic parts, and then accordingly we are moving along step by step to the next level. Okay, so the next thing that we are going to talk about is, given an IP address and a subnet mask, okay, we'll try to find out what is the network address and the host address. Okay, so if we are given a subnet mask and a subnet mask and an IP address, we need to find out what is the network address and the host address. Okay, but even before we do that, let's first try to understand this term subnet mask. Okay, I already gave you a small explanation of subnet mask, but we really didn't get into the details of that. So let's do that. So what is a subnet mask? Okay, as I told you before, subnet mask is a value again it is a 32-bit value. Okay, subnet mask is a 32-bit value that is used to determine a network address and a host address from an IP address. Okay, so I'll just modify the definition of subnet mask a bit. Okay, so subnet mask is a 32-bit value which is used to determine, okay, a network address and a host address out of an IP address. Do you get that? Okay, a subnet mask is a 32-bit value that is used to determine the network address and the host address out of an IP address. Okay, so that's the reason whenever we talk about defining an IP address on a particular device, you are not just supposed to define the IP address, you're supposed to define the IP address as well as the subnet mask. Okay, so that is what you're supposed to do. Okay, you're supposed to define the IP address as well as the subnet mask. Do you get that? Okay, so understood very clearly about subnet mask. Okay, moving along. Okay, we are now going to talk about class of an IP address. Okay, so when I talk about an IP address can be defined or divided into different classes. Okay, let's talk about all the classes of IP address. Okay, so whenever we talk about an IP address, the first octet of an IP address represents the class. Okay, so whenever we look at the IP address, the first octet of an IP address represents the class. Okay, remember that whenever we talk about the first octet of an IP address, it represents the class. Okay, so talking about the class, we have class A, class B, class C, okay, just give me a moment. Okay, class C, then I have class D and class E. Okay, these are the 5 classes that we have with regards to an IP address. Okay, so you have class A, class B, class C, class D and class E. These are the 5 classes of IP addresses that we have, and as I already told you, the class of an IP address is determined by the first octet. Okay, so whenever I talk about class A, okay, for class A, the first octet of an IP address, okay, ranges from 1 to 126. Okay, in fact 1 to 127. Okay, that's what it is. Okay, but I'll just put it up as 1 to 126. That is class A. Then talking about class B, okay, class B ranges from 128 to 191 in the first octet. Class C, when I talk about it, it is 192 to 223. Okay, that is the first octet. Okay, then whenever I talk about class D, okay, ranges from 224 to 235. And when I talk about class E ranges from 236 to 254. Okay, now that's the range of IP addresses that we can. Sorry, that's the range of values that we can have on the individual octet. Okay, so whenever I look at the first octet of an IP address, that's how I know the class. Okay, but if you look at the ranges, okay, whenever we talk about decimal values, the first octet is of 8 bits, right? Okay, so ideally, if I talk about the first 8 bits or 8 bits in general, okay, so what would be the first decimal value that the 8 bits can generate? Can you tell me? The first decimal value of the 8 bits. Do you know the first decimal value for the 8 bits? Okay, refer to the table, you'll get a clear picture. The first decimal value for the 8 bits. Okay, let me just do that for you. Okay, so in fact, let me just copy this much and then I'll talk about it. Okay, so if I talk about this particular portion, okay, let me just remove this much. Okay, so whenever I talk about the first value, out of the 8 bits, okay, the first value is typically going to be all zeros. These would be the individual bits, all the bits would be zeros. So effectively the first decimal value that you're going to get is going to be 0. Do you understand that now? Okay, now let's talk about the next decimal value. The next decimal value is going to be 0, 0, 0, 0, 0, 0, and then last bit is going to be 1. So effectively it represents a decimal value of 1. The next value that you would have is 0, 0, 0, 0, okay, and so on, and then 1, 0. What does that represent? It represents a decimal value of 2. Okay, and then again 0, 0, 0, 0, 0, 0, 1, 1. Okay, that represents a decimal value of 3. Okay, similarly 0, 0, 0, 0, 0, 1, 0, 0, that represents a decimal value of 4. Okay, 0, 0, 0, 0, 0, 1, 0, 1, that represents a decimal value of 5, and so on. Okay, so effectively what you're going to have is, like if you go on calculating it this way, the final value that you're going to get is all ones. And what did I tell you about all the 8 bits 1? What is the decimal value for all the 8 bits being 1? Yeah, that's right. That's absolutely right. It's going to be 255. Okay, so bottom line is what I was deriving at, or what I was coming to was, whenever we talk about the first octet, the first octet typically ranges from 0 to 255. Do you understand? Ideally, the first octet or any octet for that matter will range from 0 to 255. But whenever I talk about the class of an IP address, okay, we are referring to the first octet only. So the first octet means 8 bits. So naturally, it's going to range from 0 to 255. Do you understand that? Okay. So in that case, if I talk about class A ideally should start off with 0. That is what it's supposed to be, right? That's supposed to be the first value. But instead of that, it's starting off with 1. Okay, now why is that? Let's try to discuss about that. Well, whenever we talk about the first octet, okay, now the first octet is going to be on the left hand side, okay, and earlier whenever I talk about, or whenever I was discussing about the network address and the host address, okay, I explained to you one of the aspects wherein I told you the left portion is the network address and the right portion is called as the host address. Do you remember that? Whenever I was discussing about the IP address, I told you the left portion is the network address and the right portion is the host address. Okay, so in that case, if I put the first octet as 0, okay, if I put the first octet as 0, okay, which means the effective decimal value is also going to be 0, which means a network ID would be 0. You understand that? So network ID cannot be 0. Network ID has to be a value. Okay, that's the reason. Okay, I cannot include 0 in the class aspect of it. So the first octet cannot be 0. Understand that? Clear about that now? Understood this aspect? Okay, so in the first octet, all the bits cannot be zeros, or the decimal value cannot be 0. That's why you do not have 0 here. Now, if I look at class A, it goes up to 126. Okay, but class B starts off with 128. So then where is that 127? You know, 127 seems to be missing, right? Well, actually, if you look at it, 127 is also a part of class A. Okay, whenever we talk about 127, 127 is also a part of class A, but 127, okay, when I talk about it, refers to a different type of an IP address. Whenever I talk about 127, 127 represents a different type of an IP address. That is, typically it starts off at, or it's a reserved IP address, that is 127.0.0.1, okay, or it can be 127.127.1.1. Okay, I'm just giving you different examples of this address. Okay, but if you notice, all of them are starting off with 127. So 127.1.1.1. Okay, now these are some different ways in which 127 can be represented. Okay, so even though it is part of class A, 127 is not a regular IP address. Okay, anything that starts off with 127 in the first octet, this IP address is called as, sorry about that. Okay, this IP address is called as loop back address. Do you understand that? Okay, so the 127 part is called as loop back address. Okay, so any IP address that starts off with a value of 127 is called as loop back address. Okay, so these are some examples of loop back address that I gave you. Okay, so that is what we have. Okay, that is called as a loopback address, but everything else would be a regular address. But anything that starts off with 127 in the first octet is called as a loopback address. Okay, and then the number ranging from 128 to 191 is class B, 192 to 223 is class C, 224 to 235 is class E, and 236 to 254 is class E. Okay, now what is the last value that I told you for an octet? Okay, the last value is going to be all ones. All ones means it's going to be 255, right? But according to the classes, if you notice, 255 is not listed here. Okay, again the same logic. For the first octet, all the bits cannot be 1. Okay, so the first octet of an IP address, all the bits cannot be 1. But saying that, whenever I talk about 255, even 255 is a part of class E. Okay, even 255 is a part of class E, but then you cannot have the first octet as all ones, or it cannot be 255. That's the reason I had not included in this particular list here. But 255 is a part of class E. Do you understand that? Clear about that? Okay. Okay. Great. Okay. So that's the main thing about the classes of an IP address. But whenever we talk about classes of an IP address, it also includes a default subnet mask. Okay. Whenever we talk about the classes of an IP address, okay, it also has a default subnet mask related to that. In fact, whenever I talk about class A, okay, the default subnet mask for class A, when I talk about it, it is 255.0.0.0. Okay, for class A, the default subnet mask is 255.0.0.0. Whereas when I talk about class B, it is 255.255.0.0. For class C, it is 255.255.255.0. And we don't really talk about class D and class E because there it is reserved. Okay, you'll understand it more when we go ahead. But then these are the default subnet mask values for each of these classes: class A, class B, and class C. Okay. Now, when I explained subnet mask to you, I told you that subnet mask determines the network address and the host address. That's what I told you, right? Okay. But if you notice something here, okay, I'm not sure whether you are able to pick it up, okay, based on the knowledge that you've just received. But look at this. What does it indicate, or what does it tell you? I mean, just take a look at this single subnet mask. Don't think about the others. Just take a look at this single subnet mask. And can you tell me something different about this value here, or anything specific that you notice about this value of the subnet mask here? Can you see anything different or anything specific, anything that you notice? Can you just elaborate on your answer a bit? Well, not convincing enough, but okay, let me just explain that to you. Okay, if you look at this particular value here, what you would notice is the first octet, all the bits are ones. Okay, so as you notice, in the first octet, all the bits are ones, but in the remaining three octets, all the bits are zeros. Similarly, if you look at this particular subnet mask here, in the first two octets, all the bits are ones, and the remaining bits are zeros. Okay, according to class C subnet mask, default subnet mask, if you notice, the first three octets are all ones, and the last octet is zero. But overall, if you look at it, the leftmost portions, okay, the leftmost portion, you notice the bits are all ones continuously. Okay, and the rightmost portion is all zero. Do you notice that? The leftmost portion of the subnet mask is all 1, whereas the rightmost portion is all 0. Okay, so now let's try to link that to the definition of subnet mask that I told you. Okay, so bottom line is, whenever we look at the subnet mask, the bits that are 1 represent the network address. All the bits in a subnet mask which represent 1 is the network address. Okay, and all the bits that are zeros represent the host address. Again, let me repeat, whenever we talk about a subnet mask, in a subnet mask, all the bits that are ones represent the network address. All the bits that are zero represent the host address. Do you get that? Okay, so according to that, now for class A, okay, whenever I talk about class A, okay, it is effectively going to be the first octet is the network address, and the remaining 3 octets are the host. Do you understand? For class B with the default subnet mask, the first 2 octets are going to be the network address and the next 2 octets are going to be the host. Do you get that? For class C with the default subnet mask, the first 3 octets are going to be the network address and the last octet is the host. Okay, so that is, or all of this is depending upon the default subnet mask. Okay, so that's the reason it is all the more important for you to understand an IP address plus the subnet mask to identify the network address and the host address. Do you get that now? Very clear? Okay, great. Okay, so now let's get on to the next portion here. Okay, so now what we are going to discuss about is, given an IP address and a subnet mask, okay, we are going to talk about, or first of all, what is the class of that IP address. Then we are going to talk about what is the network address and what is the host address. That's what we are going to calculate out of it. Do you understand that? Okay, so let's get on to that particular portion. Now, whenever we talk about the subnet mask, as you notice, this is how a subnet mask is represented, right? Now, this representation of a subnet mask is called as decimal notation. Okay, this way of representing a subnet mask is called as decimal notation. Okay, so whenever we talk about a subnet mask, okay, decimal notation. Okay, when I talk about that, okay, the decimal notation is going to be this way, 255.0.0.0. That's the decimal notation. But saying that, if I talk about CIDR notation, okay, now I'll explain what is the CIDR notation. Okay, CIDR notation is nothing but classless inter-domain routing. Okay, now we are going to talk more about this classless inter-domain routing or CIDR a bit later, but let's now talk about the CIDR notation. Okay, so this was the decimal notation 255.0.0.0. Okay, but saying that when I talk about CIDR notation, okay, it's going to be in this format. Let me just put that up for you. The CIDR notation is going to be /8. You have to put a // and then you have to define a number. Okay, now what does this number represent? Well, if you notice in this example, for this particular example of the decimal notation of 255.0.0.0, the CIDR notation becomes /8. Now how do we get this, or how do we derive it? As you notice, in this subnet mask, only the first 8 bits are 1. Do you see that? In this subnet mask, only the first 8 bits are 1. Hence, for this kind of subnet mask, the CIDR notation is going to be /8. Do you understand that? Do you get that now? Okay. Now let's take a look at another example. If I have the subnet mask as 255.255.255.0, okay, can you tell me what will be the CIDR notation for this? This is the decimal notation. Can you tell me the CIDR notation? No, it's not going to be /32. Okay, see, you have to just count the number of bits that are ones. Like according to this much is 8 bits. Do you agree? The portion that I've highlighted is 8 bits. Okay, so 8, 8, 8, that is 8 plus 8 plus 8, that is 24. So effectively this is /24. Do you understand that? Okay, great. Now let me give you another example. 255.255.0.0. Can you tell me the CIDR notation for this one? That's absolutely right. That's going to be /16. Okay. Now let me give you another example. I'll give you the CIDR notation, and you need to tell me the decimal notation for that. Okay. So slash let's say 22. So that's the CIDR notation. Can you tell me the subnet mask for it, or the decimal notation of the subnet mask? I know it's a bit difficult, but give it a try. 255.255. Well, that's actually incorrect. Okay, it's not an issue. Just try to understand this part. Okay, now we are talking about /22. What does that mean? /22 means there are 22 bits in the subnet mask, which is 1. Okay, so how do we get that? Well, the first octet is 8 bits, so 255. The second octet, another 8 bit, that will become 16. So that is again 255. Now the third octet, if I have all the bits 1, which means it's going to be 24, because 16 plus 8 is 24. But instead of that, we have it as 22, which means, what does that mean? It means that only 6 bits in the third octet are 1. Okay, according to this, in the third octet, only 6 bits are 1. So which means what we're talking about is 1111 1100. That is how the third octet is going to be, and the fourth octet is going to be 0. Okay, so this is how it would be. Now we need to just convert the third octet from binary to decimal. So effectively it's going to be 255.255 dot. Now if you look at the binary value for this one, it's going to be 252 and dot 0. Okay, that is how it's going to be. Do you understand? Do you guys have any questions on this? I'll take one more example, and then you'll understand it better. Okay. Okay. So the next example that we're taking is /26. So can you tell me the decimal notation for this particular value? The same concept. Always remember, leftmost bits are ones, rightmost bits are zeros. Okay, you cannot have a 1010. It has to be all ones on the left hand side and all zeros on the right hand side. That's how the subnet mask could be. Okay, 255.255.255.192. That's absolutely right. Okay, it's going to be 255.255.255. That becomes /24, and then 2 more bits. That becomes 192, and that is your decimal notation of a subnet mask. Okay, so are you very clear with whatever topics we covered today? Because this is going to form the basis of what we are going to learn in the next session. Okay, because if you are a slightest of confusion out here, it's going to cause a lot of issues in our next section. So I hope you are very clear with regards to whatever we have covered until now. Okay then. Okay, so we'll stop at this for today.